the question is, right, how come there's no margin? Why is no error in the answer? Okay, so for part, let's try and entertain me. Okay, so this one here, percentage error is 0, right? If you consider two of these, right, it's 0%. It's totally 0%. There's no error, Okay, there's no error in it. So the rationale is, why is it so? Okay. Now, first thing is, look at this one. To evaluate the integral, you need x cubed, right? Agree? Right? So we look at x cubed. So let's look at x cubed. Because when x equals to 0.02, x cubed equals to is what? 0.02 to the power of 3, right? Which is actually 8 times 10 to the power minus 6. This is actually how many dp? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This is 6 dp. Agree? Any issue with that? This is how many dp? This is 2 dp, right? You see that when you cube it, right, this is 6 dp. Okay, what does it tell you? It tells you that x to the power of 4 and above will be, and above, right, can be ignored. See that? But because your answer asks you to express in 5 dp, you see that? And because x to the power of 3 is 6 dp, so of course it'll be accurate. I repeat, the rationale is very simple. You look at this x cube here. If you're using 0.02, which is very close to 0, and because 0.02 cube, right, to evaluate this root, right, cube, right, it will be 6 dp. So in other words, 7 dp and above, right, is actually not relevant in your estimate. So that's why the estimate is accurate. Okay, so that's the rationale. That is what the question is trying to ask. They're asking, how come it's so accurate? Okay, this would then be this is how, right? So since let me see how to write. It's needed. This is what I'll write. I'll try and argue that because in our integral, x cubed is the highest degree. So if it's 0.02 is actually a 6 dp. Okay. And since x4 and above are ignored, meaning 7 dp and above, because the answer of 2 and n are the same as they are corrected to 5 dp. Hence making the approximate very accurate. That's how I would think about it. Okay. So small angle, small values. Maclaurin series, we take very, very small values because very, very small value will be highly accurate because it's close to 0.